Today we're talking about simplifying radicals. So we need to define a few things and refresh your memory on what we've already discussed. Remember, a radical expression is any expression that contains a radical. Okay, that radical is what we're used to looking at like this. That part of the radical is actually called the radical symbol. If you have a number out front, this number is referred to as the index. And remember, if there is no number there, it's understood to be 2. And then underneath, let's go with, okay, if whatever number that you have or expression that you have underneath is what is referred to as the radicand. And we're going to be using that word a lot today, so I needed to make sure that you understood that. Now, an expression with radicals is in simplest form when all of the following are true. First off, there can be no perfect square factors other than 1 in the radicand. There can be no fractions in the radicand. And you can have no radicals in the denominator of a fraction. So all 3 of these things have to be true to make sure your radical is in simplest form. Okay? Now, what we're going to be talking about today is the fact that radical expressions can be simplified using multiplication and division properties of square roots. So before we get into more detail of that, I want to review our perfect squares. Okay? We have 1 times 1, or 1 squared is 1, 2 squared, 3 squared, 4 squared. Pause any time and write the numbers down if you know what they are because it's important to memorize them. 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. We could keep going. We'll stop there. 13 squared, 14 squared. Okay? And if you need to, right underneath it, we'll write, I misspelled that. Right underneath it, we'll write the roots. Okay? Square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 10, square root of 121, and square root of 144. So you have a nice little reference while you're working the problems. All right, our first property that we want to talk about is the multiplication of square roots. Okay, positive numbers. The square root of a times b is equal to the square root of a times the square root of b. For example, the square root of 48 can be written as the square root of 16 times the square root of 3, because I know that 16 times 3 equals 48. Then I simplify. What's the square root of 16? It is 4. 3 is not a perfect square, so it stays underneath. How do you know it's not a perfect square? You can put it in your calculator. When you put it in your calculator, it's going to give you a decimal like 1.732. So it would have to come out to a nice even whole number for you to bring it out from under the radical. We have a little example. Cross out the equation below that is not true. So when you look at this equation, just like I talked about right here, we're looking to see if 49 times 2 equals 98. And it does, so we're good with that. Is 100 times 2 equal to 200? It is. Okay, this one is different. So what we're going to try to do is simplify this one to see if we can get it to look like that. So just like we did up there, I know that 28 is 4 times 7. So using my property, I can break that up. And the square root of 4 is 2. Square roots of 7, well, that clearly does not equal 4 square roots of 7. So we're supposed to cross out the equation that's not true, and that's the one we're going to cross out. All right, so let's go simplify a bunch of them. I put lots of examples on here so you'd have lots of things to look at and watch. Um, the first one, square root of 225. First and foremost, put it in your calculator and see what it says. If you put, and so you can also make sure you know how to use your calculator. Put the square root of 225 in there and you should get an answer of 15. Now, if you put the square root of 128 in your calculator, it's going to give you a decimal, which means now we have got to go figure out what's the largest one of these that will go into 128. So when we talked about it, we highlighted these numbers because these, oh, let me get a fatter one here, because these numbers we're going to be using a lot, okay? And the other thing that I talked to them about was when you're looking at numbers, if it's an even number, if your number that you're looking at is an even number, divide it by 4 first. If it's an odd number, you want to divide it by 9 first. So we're going to take 128 and go on your calculator, and if you divide 128 by 4, you get 32. Well, that's kind of big. So I actually am going to jump and I'm going to see, well, if 32 goes in 32 times, I'm actually going to try 16. So I'm going to do 128 divided by 16, and I got 8. Well, 8 has a factor of 4, so I'm going to actually jump to 64. So these numbers jump, okay? Only 4, 16, and 64. So I'm going to try 128 divided by 64. Those are all powers of 2. And when I did that, I found out that 128 was equal to 64 times 2. And the square root of 64 is 8. So this becomes 8 square roots of 2. Okay? So here we have an odd one. And as I said before, if your radicand is odd, you want to start with 9. And if 9, you still have a big number left over, then the next one to try would be 81. But if you try 9 and it doesn't work, then you would continue, you could try some other ones after that. Let's see what we got here. So on number 14, it says negative 4 square roots of 117. So when you divide 117 by 9, again, I chose 9 because it was the largest odd perfect square. Because 1 goes into anything. We don't try 1. So 117 divided by 9 is 13. So that means that this is negative 4 times the square root of 9 times the square root of 13. Because 9 times 13 was equal to 117. Well, square root of 9 is 3, and we're multiplying all of this together. So that leaves me an answer with negative 12 square roots of 3. All right, look at our next group of problems. It says again, simplify each radical expression, but what's different about these, hopefully you can see, is that these have variables in them. They're not just numbers. Okay, we're going to do the same process. We're going to start with the numbers and then we're going to tackle the variables. And we've done the variables before. We're just putting them together with the numbers. So on the first one, square root of 192, again, I'm going to go try, it's an even number, so I'm going to try 4, and then I'm going to try 16, and then I'm going to try 64. So 4 gave me a 48 times, so I'm going to try 16. And that goes 12 times, so now I'm actually going to try 64, and that went 3 times. So it turns out that 192 is 64 times 3. So that gives me the square root of 64 times the square root of 3 times the square root of s squared. Square root of 64 is 8. Square root of 3 cannot be simplified, so it stays the square root of 3. The square root of s squared is s. And that's a really important thing to remember. Put it in your brain somewhere, okay? The square root of x squared is equal to the square root of x squared. So it doesn't matter if that 2 is on the inside or the outside, it's always equal to x. So in a more practical site, what might help you understand is the square root of 3 squared is the same thing as the square root of 3 squared, which is 3. Just saves you some step if you can remember that. Okay, so 3 square roots of 18 times a squared. I'm going to find a perfect square that goes into 18. Now, it's an even number, so yeah, you might try 4 and realize 4 doesn't go into 18. But divide it by 2, and you'll see that 9 goes into it. So this is square root of 9 times 2 times a squared. Okay. We have 3 times, we didn't break it up that time, but square root of 9 times the square root of 2 times the square root of a squared. That, of course, gives us 3. The square root of 9 is 3. The square root of 2 can't be simplified, but the square root of a squared, just like we've talked about here, is a. So we simplify that, and anything that's not under the radical is brought in front. So this becomes 9a times the square root of 2. Okay, looking at the next one, we have 3 square roots of 150, b to the 8th. All right, so we have 3, and we got to figure out how to break up 150. So as you go through the list, you should find out. Oh, actually, I'm going to write that one at a time. So that becomes 150 turns out to be 25 times 6. And then we have b to the 8th. Okay, so we have 3. We carry down our 3 times square root of 25 is 5. The square root of 6 is not a perfect whole number. And the square root of b to the 8th, remember we've talked about this before, but to figure out how to do that easily is to divide the exponent by the index. Now, for our problems and today, and mostly going forward, our index is always 2 because it's a 2 when there's nothing there. So divide the index by 2, excuse me, divide the exponent by the index. That's 8 divided by 2, and that of course is 4. So that's b to the 4th. And again, anything under the radical goes in front, so that gives us 15b to the 4th times the square root of 6. All right, and we have another group. And this time, hopefully you can see the difference in this group. Okay, we have some with just numbers, some with numbers and letters. But the difference in these problems with what we've done already is that now we have multiplication added to it. Okay, now you have two choices. When you work these problems, if it's on the outside, of course it stays on the outside. And if it's on the inside, oh, I'll go ahead and break it up. Let's do that. Okay, you can multiply these two together, but you're just going to have to break it apart again. So you're in better shape recognizing if you have a 6 here, see if 6 goes into 18, which it does. And then now that I have a pair, okay, this is that same thing we've been talking about right here, okay? That's this is what I'm showing is the square root of x squared. It's x. The square root of 3 squared is 3. So the square root of 6 times the square root of 6, when you see two of them together, you get to write just 6. Okay, so we're going to be seeing a lot of those. So 3, this is a times, didn't really look. 3 times 6, square roots of 3 becomes 18 square roots of 3. So you don't want to multiply it back out because you multiply it out, you're just going to have to divide it again. So I'm trying to help you see that you actually want to divide it while you already have it small. Okay? Now, you can write each one under a radical like that, or you can put them all under the same radical. So I can write 2 times 9 times, if I have 1a here and I have 3 of them there, then together I have 4 of them. Okay? So from there, I'm going to take the square root of 2 is not a perfect square. The square root of 9 is 3. The square root of a squared, just like we did up there, excuse me, the square root of a to the fourth is 4 divided by 2, which is that. So I took, this was a perfect square, and this was a perfect square. So I took the square root of 9, the square root of a to the fourth, and that means I'm left with 2 underneath, and that's all we have. Okay? So when we find those numbers that are perfect squares, we took the square root of 9 and got 3. This time I had 2 of the same thing, then I bring one of them outside. So you can think of it in two different ways. Okay, so looking at this problem, again, what's outside stays outside, so that's going to be 21. And then what's inside is 5 times 5 goes into 20 4 times. And then x and x to the fifth is x to the sixth. Okay? So again, keep in mind, there's the 5 right there, and the 5 and the 4 together make up the 20. So all three of these numbers multiply to give you those numbers. Now when I take the square root, or I simplify it, there's 2 of something. That means I get to bring it outside. This is a perfect square, so I take the square root of it. This is a perfect square, so I take the square root of it. When we take the square root of this one, we actually divide it by 2. So 21 times 5 times 2 is 210 x cubed. Okay, so that's multiplication. Let's talk about division. And in a similar fashion, the square root of a over b is equal to the square root of a over the square root of b. So if I have the square root of 36 over the square root of 49, that is equal to the square root of 36 over the square root of 49, which equals 6 over 7. Okay, so you can simplify the parts. Now, I gave you a little blurb here just to mention to you that sometimes if you will actually simplify the fraction first, it can make your life easier. Now, if I go through in a similar fashion like we just did, watch, we have the square root of 144 over 9. So that is the square root of 144 over the square root of 9. The square root of 144 is 12 over the square root of 9 is 3. And I simplify that and I get an answer of 4. Okay? If I decided to simplify the fraction first, so I'll go to my calculator and say, I wonder if 144 divides by 9 evenly. Well, when you do, you find out that it's 16. And the square root of 16 is 4. So there is more than one way to do it. Just look to see if you can simplify it first because it just keeps everything smaller when you do that. Okay, so our next problem, I'm going to again look to see if I can simplify. And I know that 4 goes into 36 and it goes 9 times. And I have 1a on top and 3 a's on bottom. So I simplify that. That leaves me with 2 a's on the bottom. And now I take the square root of 9 and the square root of a squared, and I'm left with 3 over a. Okay, and the last one, we have 25 y cubed over z squared. There is nothing that I can simplify. I don't have any common factors in the top and the bottom. So I'm treating it like the square root of 25 times the square root of y cubed over the square root of z squared. So the square root of 25 is 5. The square root of y cubed. This is a 2. Remember, understood 2. So we're doing 2 into 3. And 2 goes into 3 one time with 1 left over. So if I have 1 left over, it has to go stay in the house, stay inside. And the square root of z squared, which we've just talked about before, is z. So this is be our final answer. All right, the last thing we get to talk about today is a process that we have to use when we have a radicand in the denominator and it's not a perfect square. We do something called rationalizing, or we'll need to rationalize the denominator. Okay? So, watch what we're doing when we're rationalizing that denominator. Always, when you have a fraction, okay, or first off, look, we've got a 3 on the bottom, a radical on the bottom, which we cannot leave. 3 is not a perfect square, so I'm going to use this process of rationalizing the denominator. Now, when I do this, you have a fraction, and if you multiply the fraction by 1, then you are not really changing the value of the fraction, you're simply changing the name of the fraction. And when you do this, you always want to use the expression that you have in your denominator. So this is my denominator, so I choose to multiply it by itself, and whatever I do the top, I have to do the bottom also. So when I simplify this, the square root of 2 times the square root of 3 is the square root of 6. And as we've talked about, square root of 3 times the square root of 3 is 3. Okay? Again, remember, if you don't, the square root of x times the square root of x equals x. So the square root of 2 times the square root of 2 equals 2. That's the reason we're rationalizing. And now I don't have any radicals in my denominator. Okay? So b says the square root of 5 over the square root of 18m. So I'm going to draw my big 1. And it's just helping me remember that I have to do the same thing to the top and the bottom. Alright, and that means it's going to be, the bottom is the square root of 18m. The top is the square root of 18m, because you got to do the same thing. This doesn't look the same on the top and the bottom. Otherwise, it wouldn't be 1. So I multiply these two. On the top, I have the square root of 5, and 18 happens to be 9 times 2 times m over square root of 18m times square root of 18m is 18m. Okay, we've talked about that. That's what we did before, so the whole point is to get rid of that radical in the bottom. Okay, I got to simplify the top. So the top becomes 3, because I took this, there's my perfect square right there. So I take that out, it becomes a 3. I'm left, all this is left inside because it's not a perfect square. So that's 10m over 18m. Well, 3 goes into 18 6 times. So that leaves us with a final answer of the square root of 10m over 6m. Okay, one's underneath the radical, the other one's not. So they cannot be simplified. And yes, we could have avoided simplifying here had we simplified our radical first, but I felt at this level it was better to do it that way. Okay, last one. Square root of 7s over 3. Again, I'm multiplying by 1. And think about what we should multiply by before I say it. And hopefully you said it's going to be the square root of 3 over the square root of 3. And I multiply out. 7s times 3 is, all under the radical, 21s. And on the bottom, square root of 3 times the square root of 3 is 3. So we have covered simplifying radicals.